Okay, before anything else, I have to discuss the common terms used in conceptual and logical design. Okay, first we have the entity. So entity is an abstract or concrete thing in real world. For example, is a car or a person or a place and something that is in real world. It is represented by a rectangular shape. The second one is the attribute. It is small pieces of the given entity or a characteristic that describes an entity. So it could be a name of the person or his or her address. Contact number maybe. It is represented by an oval shape. The third one is the relationship. The relationship is association between two entities. For example, is a car a car owns owns or owned by a person. Okay, so it is represented by a diamond. Now let's go to the degrees of relationship. Degrees of relationship, this is important because we can see what kind of relationship we have in our database. So we have 3 degrees. First is unary, the second one is binary, and the third one is ternary. So unary, it means having one entity. Binary means 2 entities, because bi, and ternary having 3 entities. Okay, let's go to the notations used in cardinalities. Okay, the first one is 1. It is 2 straight lines near the entity. The second one is 1 or many, a straight line followed by a crow's feet. The third one is 0 or 1. It is a circle or oval shape followed by a straight line. And the fourth one is 0, 1 or many. This is a circle or oval followed by a crow's feet. Okay, the last one is the cardinalities in relationship. Okay, so here we have 3. This is very common because it is often discussed. First one is 1 to 1. Okay, the ratio of 1 to 1, it happens when a person marries another person, because we can't marry 2 person. Okay, the second one is 1 to many. For example, is the one patient having many histories in the hospital. The third one is many to many. So many to many happens when employees having many projects, and that's it. Now let's proceed to my ERD and its logical design. So we are assigned to create a 3 database management system, and represent it into entity relationship diagram and identify its logical design. Okay, so my first database management system is a lesson plan. So you can see uh, in this first DBMS, it has a one-to-many relationship, as the student has 0, 1 or many records. The records has only one student. So I have ready-made fields or attribute at the left side. So the student ID, last name, first name, middle initial, address, and contact number is transformed into an entity relationship diagram, which I inputted into the oval shape as the attributes of my entity. So in this database management system, a teacher would have to type and print the same details of the students that are needed. The last name, first name, middle initial, address, and contact number will be sufficed by the teacher. So the student ID from record student is used in the other tables to identify the student's information. Teachers will be able to access the students' important information and decide what to do with it. So the activity, quiz type, the num- the student ID is automatically set, and as well as the score is automatically computed. So the main purpose of this database management system is so that the teachers will don't have to have too much work. So in this lesson plan database management, the name of students and their quizzes and activities is recorded in an organized way. So most of the teachers are doing much paperwork regarding this plan, and sometimes they confuse themselves in recording every detail. So this will help the teachers in conducting the teachings and sequencing it properly. So this will give the teachers an easy work and will make their time easily managed. The second one I have here is the grocery stocks database management system. So here I have the product and supply as my two entities. So you can see it has a many-to-many relationship, as the product is how many supplies and supplies how many product. So as you can see, we have an attribute that is connected into our relationship. It means we have to set a intersection table. So in our quantity attribute, we have the product ID, category ID, supplier ID, order, and price. So I've set this because the product ID, category ID, and supplier ID is the primary keys of other table. So it has broken lines under it because we use it as a foreign key here. So for example, we have the product ID 01, the category ID is 101. For example, for our product, it is Highlands canned goods, and the category is canned goods. Supplier will be the any person market, and as you can see, the order is optional, yes or no. So we choose yes because there is no stock left, and the price is 100 and 100 peso because I live in the Philippines. 100 peso and 20 cents. So this will show a better presentation of what relationship does this database management system has. That's why I inputted an intersection table or a junction table. So as you can see, I also have the ready-made product ID, category ID, quantity left as my fields or attributes and made them inside the oval shape as the attributes of my product entity. Also here the field supplier ID and supplier description as the attributes of my supply entity. So the scenario here is to see if you're having a need of supply to your stocks and to avoid the unexpected consuming of expired goods. So the number of stocks in the database in each of the stocks is categorized according to its type. That's why it has a category, product ID, and so on and so forth. The goods that are consumed will be decreased to the stocks left field. The user will provide the details for the quantity of the stocks that is needed to order again. The supply record will identify whom you are going to buy to. So the purpose of this database management system is we ought to eat the food that has been expired without knowing that it is not okay to eat. So we can list the date that the food or goods were bought and the date that it will expire. We sometimes often to forget to buy things that we needed and we'll just be surprised if one day our toothpaste has been already used up. And if we didn't have soap already. So my third database management system is a t-shirt shop. So here I have the t-shirt order ID quantity as my entities. So the relationship is assigned because you can read it as a t-shirt, assigned quantity to order ID. And if you read it backwards, no matter which entity you start to, it is always the same. So as you can see, I have ready-made t-shirt ID, brand ID, description, unit price, bulk size, fields transformed into the attributes of my t-shirt. And also the t-shirt ID, size, color, quantity as the attributes of my quantity, and the brand ID, color, quantity, and price as my attributes in the order ID. So there is a attribute that is connected into the relationship, which is the order list. So here I have an example of the table, of the intersection table or junction table that I represented into a table so that we can understand clearly what is the purpose of this attribute in the relationship. So I have the order ID, for example, is 121. The product ID is 111. So always product IDs. I think that will be the ID of, for example, is a Kentucky t-shirt or a Whistler t-shirt. So yeah. So the quantity is 12 and date ordered is February 24, for example, is 2018. So here I've used order ID, product ID as the foreign keys in my table, which as you can see is the primary keys in the other table. So this order list this is the finalization of the order ID because we computed the price in the order ID, and if it is done, it will be preceded to the order list. So as you can see, the number of t-shirts is updated from time to time. For each brand, size, and color of the t-shirt, there will be a reasonable price. The more the customer order, the more discount he or she will receive, because you can see we have the unit price and the bulk size and the bulk price. So as the customer orders, the order ID record is more detailed. It will sum up the price that the customer has ordered. As the order ID are made up, the date, which the time that the customer ordered is applicable and is ready to purchase. That will be inputted into the order list, as I've said before. The quantity of the left t-shirt, colors, sizes, and brand will be updated, and the bulk price is fixed on 5 or more t-shirts. So I've said it, so 5 or more t-shirts. So the purpose of this database management system is before before I'm recording the details in the small notebook. So it is very confusing, and sometimes forget what information I've inputted into it, or where is the notebook. So this database management system can organize the t-shirts much more and can easily find the needed information in one handler. So since there are many t-shirts, we do not have all the time to count them. So using this database management system will make the business more handleable and manageable. So we can track the production and compare sales from previous season and from time to time. So the last thing I wanted to show you is the representation of relationship. It is the part of a logical design. So in my first database management system, which is the lesson plan, I have the student and record entity having a binary one-to-many relationship. Because it has two entities, that's why it is binary and one-to-many relationship. As you can see, the cardinalities, the notations I've used here is two straight lines near my student entity and an oval shape followed by a crow's feet near my record entity. So it means student having 0, 1, or many records. So here we can have a record having a multiple student. So the same as the grade. We are referring to the grades. We can have multiple grades in a main subject that is owned by a student only. So the second one is the grocery stocks. You can see it has a binary many-to-many relationship. So the product entities, the product and supply entities having many-to-many relationship, because you can see it has a notation of oval shape followed by a crow's feet, the two entities. So it has many-to-many relationship because we are talking about goods here. So goods we are referring to as the shampoo, toothpaste, or ready-made noodles ready to cook. In supply, it has an optional 0 because stocks can be left out. So I have here the quantity that is in the relationship, that is connected in the relationship. So I have discussed it previously and why we have the quality here. It is a very important thing. So the third one, the last is the relationship of my t-shirt shop. So it has a ternary relationship because I have a t-shirt order ID and quantity as my entities. So this one is not really tolerable because having many entities will just confuse a database. So if it is important to have a ternary relationship, you can allow it, or not just ternary but multiple entities. So in my case, I have a straight line and followed by a crow's feet near my entities because this ternary relationship is having a many-to-many relationship. So we are not tolerating many entities or multiple entities here in a database management system, but for as long as it is important, it is allowed. So, okay, that's all. So if you want to learn about the next step of this conceptual to logical design, uh, search for the normalization step. So, there you can, the data is normalized and stable. Okay, again, thank you for listening and for watching. So we are not tolerating many entities or multiple entities here in a database management system, but for as long as it is important,